In this video, I'm going to show you how you can use Terraform to manage AWS resources. We're going to go through setting up a project on our local machine that uses Terraform, and then we're going to create a simple EC2 instance, and I'm going to show you how you can configure that instance and how we can connect to it from our local machine. So you're going to need some prerequisites for following this video. I've put all of the links to all of the dependencies that you need to have installed in the description. So please pause the video and go ahead and make sure you have all of that installed. You should have Docker Desktop if you're on Mac or Windows, because Docker Desktop comes with both Docker and Docker Compose. If you're on Linux, then you can just install Docker and Docker Compose separately. You're also going to need to have AWS Vault, because we're going to be using AWS Vault in order to authenticate with AWS on our local machine. Additionally, you're going to have an AWS account with an administrator IAM user that you can use to create the instance in AWS. Once you have all of that installed, let's get started. So the first thing we're going to do is set up our IAM credentials in our AWS account in order to authenticate. So open up your AWS console and head over to IAM. Then you want to locate users and select your user. So I have a user here marked or Winterbottom. You want to click on the Security Details tab. This is where you can create access keys that can be used to authenticate with AWS from the AWS CLI on our local machine. So Terraform needs these credentials set up on our local machine in order to connect to the AWS API and perform the actions it needs to manage our AWS resource. So underneath this access key, you're going to click Create Access Key. This will create a new key for you. So this is basically a user ID or an access key ID, and then a secret access key. You obviously want to make sure that your secret access key is always kept secure, and that's why we use AWS Vault to manage the credentials. So we don't have to store it in a clear text file on our machine. All right, so first copy the content of your access key. Then open up the terminal, or if you're on Windows, the command prompt window, and type AWS Vault add, and then the name of the user. So I'm just going to call mine MW for short, Mark Winterbottom. And then hit enter, and it will ask you to enter the access key. So I'm just going to paste it in there, and then it's going to ask you to enter the secret access key. So I'm going to head back over and I'm going to show this, and I'm going to copy the contents of the secret access key. And again, remember, never share your secret access key with anyone. And I'm going to paste the secret access key here in the box and hit enter. Now it's going to ask me for my keychain password. Because I'm using Mac OS, AWS Vault will store all of the credentials securely in the keychain. Okay, so now we've added that, we need to set up MFA or multi-factor authentication. So once you add this to AWS Vault, it's going to create a new file on the system, and that file is located inside .aws/config on the local machine. So I'm going to open up that file so we can configure our MFA token. So I'm going to do VI and then the tilde, which means home /.SSA or not .SSA, .aws/config, and hit enter. This will open up the AWS config that we just added. So you can see that it's already added the profile MW that we added to AWS Vault. Now what we can do here is add some new lines. So we're going to start by adding a default region that we're going to be working on. So I'm going to be using the US East 1. So region equals US East 1. Then below that, we can put MFA_serial equals, and this is going to be the MFA device serial that we're using for our AWS account. So if you head back over to the AWS console, you can close that. You can see here underneath security credentials, I have an assigned MFA device. Now, if you don't have an assigned MFA device already, then you can just click a button that would appear here, which will allow you to add it. So you just click manage, and it will allow you to follow the steps to add multi-factor authentication using the Google Authenticator app or the Authy app or whichever app you like to use for multi-factor authentication. So I'm going to copy the contents of this line here and head back to the terminal and paste it in. So this pastes in the MFA serial. Okay, now I'm going to save this file, and then we're going to authenticate with AWS. So I'm going to type AWS Vault exec, then the name of the account, and then -- duration equals 12 hours. So what this will do is it will allow me to authenticate with the AWS CLI for 12 hours, which is the maximum it allows. Now, of course, If you need it for less time, then you can just put less time in here. So you can put 1 hour, or you can leave it as default. The default, I believe, is 1 hour. Okay, so I'm going to hit enter, and now it's going to ask me for my MFA token. So I'm going to go ahead and get that, and I'm going to paste that in there. Okay, so now it's asking for my keychain access again, so it can store these new credentials, and you can see that it goes through and it adds the credentials. Now, what it's done here is it's added environment variables to our session here in the terminal that allows us to authenticate. So it will add this secret key and the ID, as well as a temporary token that is generated when we authenticate with multi-factor authentication. Okay, so the next thing that we're going to do is we're going to add an SSH key to our AWS account that we can use to authenticate with our server that we create. So we're going to be creating an EC2 instance, or a virtual machine, and we need to be able to connect to that using SSH. So I already have an SSH key on my machine. If you don't already have an SSH key, then go ahead and generate one. If you don't know how to generate one, then there's many different guides on the internet if you search Google for how to generate an SSH key. And by default, they're in the home directory under .ssh, and the key that we want is the ID rsa.pub. So I'm going to type cat, the tilde character /.ssh/ID_rsa.pub. This will output the public key for the default key that I have on the system. So the default key is stored under ID RSA, and the public key is .pub after ID RSA. Okay, so I'm going to copy the contents of this and then head back to the AWS console, and we need to add the key to the AWS console so we can configure it in Terraform to add it to our Bastion instance. So if you click on services and you go to EC2, you have an option here on the left-hand side for keys, so key pairs. It's underneath network and security. Click on key pairs, and then you can click actions, import key pair, and give it a key pair name. So I'm going to call it Mark MBP, which is MacBook Pro, is what the key is for. And you need to remember the name that you add here, because we're going to be needing it when we reference it in our Terraform. Okay, so once you've added the public key here, you can click import key, and it will go ahead and create a new key within our SSH keys. The next thing we're going to do is set up our project to start adding the Terraform code. Open up your terminal or your command prompt window and navigate to the location where you want to create the project. So I'm going to create it in this demos directory here. I'm just going to clear this so we can reset it. And I'm going to do mkdir tf AWS. This is the Terraform AWS project. Then you want to change into that project and open it up in your text editor. So I'm going to be using Visual Studio Code. So I'm going to do code dot, and this should open up Visual Studio Code with the project location. So the way that we're going to be managing our Terraform version is we're not going to be installing Terraform directly on our machine. We're going to use Docker Compose and Docker to run the Terraform for our project. The reason we do this is it makes it easy to manage the Terraform version for a particular project. So if you haven't used Terraform before, then you need to know that Terraform versions are not necessarily backward compatible. So if you have a project that uses Terraform and you're using Terraform version 1, for example, then when you use version 2, it's going to upgrade that project to use version 2. So if any other developers are using Terraform on that same project, but they're using the original version 1, then it's going to break the Terraform code when they run it, because when you run it with a newer version, it automatically upgrades the project to that version. This is why I recommend using Docker Compose to manage a Terraform version. That way you can lock the version that you're using to that particular project. So you can define which version of Terraform you're going to be using to manage the Terraform of that project. It also means that it's easier to install. You don't need to actually download Terraform and install it on your machine. You can just have Docker and Docker Compose installed, which most developers do have installed nowadays, and then you can immediately run Terraform. Okay, so in the root of our project, we're going to create a new file called docker-compose.yml. Then we're going to populate this with the Docker Compose configuration to run Terraform. I'm going to start by writing version and then 3.7. So this is just the version of Docker Compose that we're going to be using. Then we're going to define services, and then the service tf, We're going to use image HashiCorp /Terraform 0.12.24. This is the current version of Terraform, and there is official Docker images available for HashiCorp Terraform. So if you head over to Docker Hub, which I have here, you can see that in Docker Hub, there's the HashiCorp/Terraform repository, and that has a list of tags with all the available ones. So currently the latest specific version available is 0.12.24. Now that we've added that, we can add volumes. So type volumes : then --infra. So what this does is it tells Docker Compose to run our service and map a volume of our local directory. That's what the dot indicates. It's the local folder that you're in, and map it to /infra. So this way we can add our Terraform to our project, and then when we run our service, Docker Compose will make sure all the files in our project are available to the running Docker container that's going to run our Terraform. So this is how you get the code files from our project into the Docker container. Okay, then we're going to specify working_dir/infra. So this just tells Docker that the directory we're going to work from when we're running the commands is this /infra directory that we've mapped our project to. So when we apply our Terraform, it can access the files. Next, we're going to specify the authentication. So we're going to specify environment variables that pass the variables from our local machine, where we've authenticated with AWS Vault, into the running Docker container. So the way we do that is we type environment : AWS access key ID equals then $ open braces, and then the same thing again. So we're going to paste this in. So what this syntax does is it pulls in the environment variable set in our machine for AWS access key ID, and it passes it to AWS access key ID within the running Docker container. So this is how we pass our authentication credentials from our local terminal or command prompt window into the running Docker container. So then Terraform, which is running in Docker, can authenticate with AWS. So we're going to do the same here for the AWS secret access key. And again, we're going to pass it in. And AWS session token. And again, I'll copy and paste that. Okay, so save the file. And that's our Docker Compose file. So this will allow us to run Terraform on our local machine through Docker using Docker Compose. All right, so the next thing that we're going to do is we're going to be setting up our first Terraform file. So let's create a file in the root of our project called main.tf. So Terraform files can be called whatever you want as long as they end in .tf. So you can add as many different Terraform files. You can split your project up into multiple different Terraform files if you have a big project with lots of Terraform, or you can just keep it all in one file. And it doesn't matter where the files are as long as they're in the root directory. It doesn't matter what order they're in. All that matters is they're all in the same directory and that they end in .tf. Okay, so the first thing we need to do is define the provider. So the way Terraform works is it uses various different providers to communicate with the cloud service. So the great thing about Terraform is it's not just compatible with AWS, it's cloud agnostic. It has many different providers. If you head over to the official Terraform documentation and you click on Docs Providers, you can see it has a wide list of all different providers for various different cloud platforms. So the one we're going to be using is, of course, the AWS provider. So we need to define that at the top of our Terraform. So we type provider and then AWS in quotes here. And then we can pass in some various configurations to our provider. So this basically tells Terraform that we want to make sure that this provider is available in our Terraform because our Terraform is going to need this provider in order to communicate with AWS. If you were using Google Cloud, then you would have to provide the Google Cloud provider, or if you were using any other cloud platform, you would provide the appropriate provider for that cloud platform. So we're going to specify the default region so we can ensure that the Terraform is being ran on the correct region. So I'm going to type region equals US-East-1. It's the region we'll be using. And then we're going to specify the version of the provider that we're going to be using. So if you go version equals, and then we're going to use the tilde character more than 2.61.0. So if you head over to the Terraform provider page, I'll put a link in the description of the video as well, then you can see that the latest version is 2.61.0. And the reason I like to lock it down to a specific version is just in case Terraform does any updates to this provider that breaks our code. So we can then manage the version that we're using and we can plan to upgrade in the future. We don't have to take the latest version every single time we run our Terraform. Okay, so head back to the project, and just to explain this tilde character here, so what this says is update to the latest patch version of this minor version that we have here. So we're going to always have 2.61, but if they release 2.61.1, then it will automatically take that. And that's because the patch versions typically have breaking bug fixes, or they have things like security fixes. So that's why we want to use this tilde syntax here. That's how you set up the provider. Next, what we need to do is set up our actual instance. So once you've defined your provider, you can go to the documentation for the provider. So if I go over to the Terraform docs and click on Major Cloud, and I'm going to choose AWS, you can see all of the different resources that are available for Terraform. So this tells you what you can define in Terraform that it will create in AWS, or it has all of the details about all of the different configurations that you can put in your Terraform for the different AWS services. So we're going to be using EC2 instances. So in the filter here, I'm going to type instance, and this will allow us to filter to EC2. Now there are two main types of data types. So you can define resources, which actually manages a real resource in AWS, so for example, a real EC2 instance, or you can define a data source, which is used for retrieving an existing instance in AWS. So if you had some existing configuration in AWS that you wanted to reference in your Terraform, maybe you have an EC2 instance that's created by a different Terraform project, then you can use the data sources to get a handle on that and pull details in Terraform for that resource. So we want the resource for AWS instance. So this tells you how to use the AWS instance resource. So this bit here, the resource AWS instance, tells you how to make a simple instance in Terraform that will be managing an EC2 instance in AWS. So what we're going to do is head back to Visual Studio Code, and we're going to define our instance. So I'm going to type resource and then AWS instance, and we'll call our instance web. Let's pretend this is going to be a web server. Then you define the AMI. So that is the image that is going to be used to build the instance. So it's a required field. Whenever you define an AWS instance, you must provide an AMI. And we're going to get the AMI by heading into our console in AWS, choosing Services EC2. And if you click on Launch Instance here, you can see it brings you to this page here. So the page that has the different images that you can use. We're going to use Amazon Linux 2 for this demo, and you can see the AMI ID here. So we're just going to copy the AMI ID from Amazon Linux 2, and I'm going to head back into Visual Studio Code, and I'm going to type AMI equals, and in quotations, the ID of the AMI that we're going to use. Then we can type the instance type. So if you type instance underscore type equals t2.micro. So if you've used AWS EC2 before, you know that the instances that you create in AWS are defined by their type. So the type basically determines how much memory and CPU power is given to that instance. The T2 micro is a cheap, low entry level instance. It doesn't cost much to run, but there will be a charge if you're not using the AWS free tier. You will be charged when you create this instance, but usually it's just a few bucks a month, maybe $10 a month. You have to look at the costs in the AWS cost calculator to get the latest costs. So we're going to be creating this instance, and then we're going to define the key name. So you type key underscore name equals, and this is the name of the key that we created in our keys in EC2. So if you go back to your EC2 dashboard and you look at the key pairs, you want the name of the key that you created. So our name, or the name I created, was called Mark MBP, MacBook Pro. Okay, so I'm going to paste that in there. And this tells Terraform when we create the instance, pass this key into the instance so that we can use this SSH key to authenticate. All right, so next we're going to define the security group. So we need to add a security group to our instance in order to make certain ports open so we can actually connect to it. So below this resource here, we're going to create a new resource at the bottom called resource AWS security group. And we're going to call this one web. So the syntax of Terraform, I didn't explain it very well up here. So basically you define the type of resource. So this is the type of resource that you're referencing, and it's all defined in the AWS or in the Terraform documentation. Like for example, AWS instance. And then you define the name that you're going to use to reference that particular instance in your Terraform. So this is what you decide, and this is what is listed in the Terraform documentation. So you can create multiple different instances, and you could create Web 1, Web 2, Web 3, or you could create a SMTP server and call it SMTP. You can call it whatever you want. It's used for your reference when you're accessing the resource in Terraform, when you're writing the Terraform code. I'm going to show you a demonstration of that in a moment after we create the security group. Okay, so we have our security group, that's for our web, and we're going to give it name equals web security group. So we'll just describe it, basically what the name of the security group is, and then we'll give it description equals allow access to our web server. This is just a user-friendly description that you'll see in the AWS console. All right, now we need to define the rules of the security group. So we're going to specify ingress, which means inbound. So ingress is inbound, egress is outbound. Ingress is connections into the server, and egress is connections away from the server. So you can see this defined in the Terraform documentation. If you search for AWS security group and you look for the resource for the security group, you can see it explains here ingress, egress, and how you specify all of the different definitions. Okay, so we're gonna type description equals allow SSH. So this is a rule, an ingress rule for allowing SSH to our server. All right, from port equals 22 to port equals 22, protocol equals TCP. So port 22 is used by default for SSH, and it uses the TCP protocol in order to connect. Then we're going to specify CIDR blocks. So CIDR_blocks equals, and this is the CIDR blocks that are allowed to connect. So we're going to open it up to the world. So we're going to say any location, any IP address can connect into our server. So it's publicly open. Of course, they would need the valid SSH key in order to authenticate. So not everyone will be able to access it without the SSH key, but you would actually be able to connect to it if you had the SSH key from anywhere in the world. So we type 0.0.0.0/0. This is practically a wildcard CIDR block. It just says allow connections from everywhere. Okay, so now we've defined a security group here, we can add it to our AWS instance. So if you were creating the instance in AWS, you would create the instance, and then you would create the security group and assign it to the instance. So the way that you assign the security group to the instance is you're going to type security_groups, plural, equals, and then a new list object here. So a new square bracket. And in here, you can put all of the security groups that you want to assign. So you could put multiple security groups if you wanted. And you can reference this new security group by typing AWS security group.web then name. So the name of the security group will be passed in. So notice that we have the AWS security group that matches the resource name and then the name that we gave it. So web. So we could call this web 2, and then we would have to change this to web 2. So this is the name that we provide the resource. Then you do .name, which references the name of the resource. So actually, I'm going to change this name here to just web-security-group to give it a snake case name, because I don't think you're supposed to have spaces in the security group's names. Okay, so the next thing we're going to do is define tags on our AWS instance. This can just give our instance a nice user-friendly name when we're managing it in AWS. So if you type tags equals and then name equals, and we'll just call this web server by TF. So it's by Terraform. So it's a web server created by Terraform. Okay, so finally what we're going to do is add what's called an output resource. So at the bottom here, we're going to type output and then instance public DNS and value equals AWS instance.web.public DNS. So what this does is it defines an output block for our Terraform. So this means when we run our Terraform, after it's completed applying the Terraform to AWS and it's created our security group and it's created our instance, it's going to output this to the screen, to the terminal console log. And what it will output is the AWS instance.web.public DNS. So that is the AWS instance.web. It's this resource that we created, our EC2 instance. And it is the public DNS for that instance. So it's the public DNS name that we can use to connect to the instance. If you go to the Terraform documentation and we go back to the instance docs, AWS instance, you can see it lists all of the different attributes that are available here. So you can use any of these options here. So you can access any of the arguments that are created or any of the attributes that are defined at the bottom. So attributes are things that you can't actually define in the Terraform. They're things that you can access from the instance using output. So things that you can access once you've created it. And you can see public DNS is the public DNS name assigned to the instance, which will allow us to connect. Okay, so now that we've added all the Terraform, we can go ahead and actually run Terraform for the first time in our project. So just make sure that you've saved the file. You want to make sure you've saved both the main.tf and the Docker Compose file. Then we're going to head back to the terminal, or if you're on Windows, the command prompt window that has already authenticated using AWS Vault. So you want to already have ran that AWS Vault exec and then the name of the account that you're authenticating with and make sure that that's all authenticated. Then you're going to type Docker Compose with a hyphen run --rm tf init. So what this will do is it will run Docker Compose, which will immediately access our default Docker Compose file, which is called, it looks for docker compose.yaml by default from the current directory. And it's going to run our TF service. So run our TF service, and the RM flag here basically says once you've run the container and it's finished running, remove it. So we don't have all these lingering containers that stay on the system every time you run them, because we only need to run the container to run our command, and then we can clear it to keep it clean. Then we pass in the init command into Terraform. So it's the Terraform init, which stands for initialize. And what that does is it pulls down the provider from the from the Terraform provider's registry, and it pulls it to our local system. So I'm going to hit enter there. And it just takes a moment because it has to search for the provider, and then basically, I think it clones it from Git behind the scenes, but basically it pulls the provider from the remote repository to our local machine. And you can see here, as we've ran the command and as it's processing, it's added a new Terraform directory, which is a hidden folder because it's prefixed by a dot. And inside you have the provider here. So you want to note that if you are committing this to Git, you want to make sure you're using a Terraform git ignore file. You want to ignore everything in Terraform. You never want to commit these to Git. You want to make sure that they're created from fresh every time you run Terraform on a machine. Okay, so now that we've initialized successfully, we can go ahead and run the format command. So if we look at our main.tf, Terraform has a handy format command that allows you to format your Terraform to make it look really neat and tidy. So if you go to terminal, we're going to run the same start of the command again. So docker compose run rmtf, and I'm going to type fmt, which stands for format. You can see it reorganized our file and it lined up all of the equal signs so all of the arguments look neat and tidy. Okay, so next we're going to run validate. So Terraform also has a validate command, which will validate that our Terraform is valid. So it will tell us if we have any typos or reference errors in our Terraform. You can see that it's successful and it has validated successfully, which is good. Next, we can run Terraform plan. So there are three main commands that you run when you're actually applying Terraform. There's Terraform plan, which will plan the changes. So that's a command that doesn't do any actual changes to AWS. It just tells you what it would change if you applied the Terraform. So if you run the docker compose run /rmtf plan command, then we're just going to let this run, and it will go ahead and connect to our AWS account, and it will look at our Terraform and it will compare the Terraform that we've added to what's already created in the AWS account. So you can see we haven't ever ran this Terraform in AWS. So it says there are 2 items to add. That is the security group, the web security group, and the EC2 instance. So it gives you all of the details of everything it's going to create. And it's a good practice to have a read of this before you actually apply your Terraform. You want to make sure you understand what it's doing, because if you have an AWS account that has different projects, or you're using a Terraform that is actually managing a production service, you want to make sure that you're not deleting anything that you're not supposed to delete, or that you've made a change in your Terraform that's going to remove an instance or remove some data that you want to make sure is kept persistent. So you always want to make sure you read and understand what it's going to do. And you can run Terraform apply. Now the Terraform apply, it's going to do the same plan first, but the apply actually makes the changes. So once you run apply, it will ask you to confirm before you actually apply the changes, but it's going to output the plan again, and it's going to ask you to type yes. So just know that once you type yes and you hit enter, it's going to create our instance and our EC2 instance and our security group in AWS, and then you're going to start getting charged for that instance. So it's not going to be very much, it's pennies per minute, and you only need to have it running for a minute to do the demo. So it shouldn't cost much at all, but just be aware that there will be a charge. So I'm going to type yes here, and then I'm going to wait, and it is going to go ahead and create the instance. So as soon as you type yes and you hit enter, it actually starts creating the instance in AWS. So you can see that it's already created the security group. And if we head over to our EC2 console, so you go services EC2, you can see it being created. You can actually see the instance in running instances. You can see it's actually creating our instance right now. So you know that the Terraform is being applied. Now it takes a few minutes to create the instance, or maybe it's a few seconds now. I think AWS have sped it up recently. Basically, it depends how long the cloud platform takes to create the instance, but Terraform is going to wait for the instance to be created, and then it's going to output the output that we defined, which is the instance public DNS. So you can see now in the AWS console that the instance is running, and these are just some old instances that I created earlier. You can ignore them. You can see the instance is running, and you can also see the public DNS here, but it's quite handy that it's output the public DNS in our console right here. So what we can do is copy that and do SSH, and we're going to connect to the user EC2-user. So this is the default user that is created in the AMI that we use. So that is the Amazon Linux 2. Then paste the host name and hit enter. And you can see it asks us to add the fingerprint. I'm going to type yes. And then we can SSH to the server. So now we have access to the server. We're now connected to our EC2 instance. And if we want, we can do sudo shutdown -h. And this will actually power off our instance. So you can see, just to prove that we connected to it, you can see that the instance should start shutting itself down in a moment. We'll just wait for that to complete. Actually, we need to type -h now, so then it actually shuts down. So we did -h now, okay. Now it says running. Now it says stopping. So it's actually started to shut down the instance, and we initiated that via SSH. Okay, so the next thing that we're going to do is I'm going to show you how you can destroy your AWS instances. So the beauty of Terraform is it allows you to define all of your infrastructure as code. So you can define all the infrastructure in your source code, and you can easily create and destroy instances. So you can not just create and destroy instances, but you can create and destroy all of your Terraform. So if you had 100 different AWS services that you defined in your Terraform, you can create them and destroy them within a few seconds on your AWS account. Well, maybe a few minutes, depending on the resources you create and how long they take to create and destroy. But you can basically automate that process. So you can very easily create and destroy your infrastructure. So the way that you destroy is, instead of typing apply, you're just going to type destroy and hit enter. And then Terraform's going to go ahead and tell you what it's going to do before it actually does it. So it'll ask you to confirm. And we'll just wait for that to process. It'll basically refresh the state and run the plan again. And it will tell you it's going to destroy 2 items. So it's going to destroy our security group and our EC2 instance. Okay, so I'm going to type yes, hit enter. And then if you go back to your AWS console, you can see if you refresh that it's going to destroy our web server. So we didn't actually terminate the server when we shut it down, we just shut it down. So it means it was in a stopped state. We could start it back up again if we wanted, but what we're doing now in our Terraform is we're destroying it. So we use the Terraform destroy command. You can see that it has successfully destroyed both of our resources. That was our security group and our instance. And it sits in the terminated state for I think up to an hour, and then eventually that will automatically get cleared off. Okay, so that's how you manage AWS using Terraform. I hope that you found this video useful. If you did, then please give it a thumbs up. And also, if you want to learn more about Terraform and deploying some more complex infrastructure, then we have a new course available, DevOps Deployment Automation with Terraform, Docker, and AWS. And we will link to that in the description of this video if you want to go ahead and take that course. Otherwise, stay safe out there, and I hope you found this video useful.